started with the process of it, do we remember our perfect squares?
3, 4, 6, 8, 10.
Try again. First perfect square is
5, 7, 35.
4, 9, 16, 25. Yeah, where did I put them?
I got this square root. Is this our homework?
No, that's the in class. 36 followed by 49. Let's see how high you guys can go.
64.
81.
81, 100,
146.
144.
Do you want to raise your hand?
I think 196.
Missing some.
210.
No.
I'm
Don't
kidding.
just guess.
I'm kidding. I'm kidding. That was a joke.
209.
So 13 and 14 are kind of easy to remember because 13 is 169 and 196. 15 squared?
225.
225. 16 squared?
Okay, that's enough.
Wait.
I think it's
Oh, never
289.
mind. You already got 144.
289? Or am I making that up? 16 squared. Oh, I am. I always do that. I missed 256. 256, then 289 is 17 squared. Okay. Followed by 18 squared. I think it's 324. Yeah.
I just got that missing worksheet from the other day.
Yeah, you can check to see if I have it in there, Maddie. 19 squared. 361. You guys should know 20 squared.
240.
400, right? Because 2 times 2 is 4 with 2 zeros. We won't go any higher than that. I think, personally, when you graduate high school, you should be able to say up to 12 squared. I mean, that should be kind of a given, right? You should kind of have up to 144 memorized. I mean, that's just something you should know. Now, the purpose of perfect squares is when you take the square root of them, what happens?
It goes back to this number doubled by.
It goes back to that number that you doubled it by, right? Or not doubled it, multiplied by itself, right? Because doubling would mean times by 2.
Yeah.
361, yes. And then 400. So if you take the square root of 4, what do you get?
2.
2. So the square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 16 is equal to 4. The square root of 25 is equal to 5. So if we were to take the square root of any of my perfect squares, it's going to end up as a whole number. Okay? Now, the reason why I want you to remember the perfect squares is when we simplify our radicals, I'm going to use my perfect squares. So I'm going to quickly list them up here on the board.
Another question.
What?
You can't have negative square roots, right?
Correct. 25, 36, 49, 64, 81, 100. All right, so please write the following steps down for simplifying radicals using Mrs. Crowley's method. Step 1, you're going to find the largest perfect square which will divide evenly into the number under your radical sign. So we want to find the largest perfect square which will divide evenly into the number under your radical sign. Okay. Step 2. Going to write the number appearing under your radical as the product of the perfect square and your answer from dividing. All right, so step 3. Give each number in the product its own radical sign. Step 4, reduce. The perfect radical. And I put perfect in quotes because that's going to be the one with the perfect square underneath it. And then step 5 is very important. This is where you're going to not get your answers correct because you'll forget to do this. Step 5 will be check that the number remaining under the radical cannot be divided by another perfect square. Okay. So it's a lot of steps, but it goes quick. Just wanted to write it out so you had it. So once you have that, flip on to the back. We'll look at our first square root that we need to simplify. So the first one we have is the square root of 48. So I need to find the largest perfect square that divides into 48. So I know that 4 divides into 48. Are there any other numbers that divide into 48? Does 9?
No.
Does 16?
No.
Yes. 16 times what is 48?
2.
3. Does 25 divide into 48? 36. Now I just exceeded 48, so I can't go any higher. So which out of those two circled numbers is the largest? 16. Okay, so I found my largest perfect square that divides into my number evenly. Now I'm going to write it as a product, and if you are a lover of branches, feel free to make branches. But I'm going to write it as the product of those two numbers. So 16 times 3 is 48. True? Now I'm going to assign a radical sign to both of those numbers. I'm not going to make more branches. Now I'm going to reduce my perfect radical, which is 16. The square root of 16 is 4. And then I'm left with the square root of 3. The square root of 16 is not, and students will do this, is not the square root of 4, which then goes down to a 2. The square root of 16 is just 4. Now, last step, step 5. Check to make sure that no other perfect square divides into the number remaining. Can I divide any of these perfect squares into 3? No. So now I know I'm done. Okay? If you want to keep doing all your branches, that's fine. If on Tuesday, just watch, don't put this, you guys did 224, right? Then you did 2 and then 12. And then you guys did 2 and then 6. And then you did 2 and then you did 3. And then you found your pairs. That still is going to get you to 4 square root 3. Me personally, I see this as a little bit more clean cut. Because it gets me right there.
If it's okay if I just do everything under the radical and not make them there.
Yeah, that's fine. As long as you get there, that's all I care about. Okay? Owen.
If the 3 in the square root was 9, then I'd go down to like what it is now.
The 3 under this 3
Yeah.
was a 9.
Yeah.
Then you would, so you have 16 times 9?
Yeah, I know that wouldn't be the answer. Add 48, I'm just saying, it sounds like it.
And the 48 if it was a 9.
So if it was like,
So if it was 16 and 9 as your branches,
Yeah.
then the square root of 16 is 4. The square root of 9 is
3.
3. 4 times 3 is 12. So that means probably the number underneath the radical sign was 144, which is a perfect square.
it'd just be
So
12.
if both of your branches are perfect squares, then this probably was a perfect square.
Is that ever gonna happen?
Yeah, that could happen. Now, watch again, don't write this. Let's say you did not realize that 16 was the largest perfect square, but you knew that 4 was. So you did 4 and, what would that be? 12 as your 2 branches. Well, the square root of 4 would reduce to a 2, but now I'm left with the square root of 12. This is where that step 5, Sam, put it away, would come in very handy. Does any other perfect squares divide into 12? 4. 4 times 3, which that would go to a 2 square root 3. And since I had a 2 originally out here in front, I would multiply these two 2's together to get to that 4 square root 3. Okay? So you have to make sure you check it. Make sure it can't go any further. All right, let's do the next one. What is it? The square root of 50? Largest perfect square that goes into 50. 25 times 2. Give both of those numbers a radical sign. Reduce to the perfect radical, because that goes in front. So it'd be 5 square root 2. We're going to skip the fractions, go over to the right. We'll do the fractions last. So over to the square root of 72. Largest perfect square that goes in 72.
9 and 8.
All right, so we're going to go 9 and 8 because that's what Kyle went with. Yeah, 36 does work, but we'll do 9 and 8. That's okay, because this is probably what I would do too.
It's going to be 3.
3 square root 8. Can I simplify the square root of 8 further?
Yeah.
4 and
Really?
2, which goes to 2 square root 2. So what do I do with this 2 and this 3?
You multiply.
Multiply to get
6
6 square root 2. Taylor noticed that it was 36 times 2 right away, which wouldn't that get you to 6 square root 2? Yeah. If you can find the largest, yes. Yeah. So the trick is finding the largest. Okay. All right, let's go to 120.
I don't get it.
Multiply. Yeah.
You only simplify the one on the left is the only one that isn't in the radical.
Right.
36.
So my largest perfect square is 4 times 30. Square root of 4 goes to 2, and I'm left with the square root of 30. So that number's kind of large. Can I divide any perfect squares into 30?
9?
15
Is that a perfect square?
plus 1.
True, but is it a perfect square? No. No, I can't divide 4 into 30. I can't divide 9 into 30. 16 does not go into 30. 25 doesn't go into 30. Now I've just exceeded it at 36. So that means that is my simplified form.
Wow.
Okay. All right, so now let's go to the 2 fractions. So when you are simplifying fractions, you're going to take the square root of the numerator and the square root of the denominator individually. What number will result in my numerator? 4. What number will result in my denominator? 5. Good. That's it.
Whoa.
if this instead of 16 was 1, what's the square root of 1? 1. So that would be 1/5, right? All right, and then the last fraction one, we're doing the square root of 8 over the square root of 9. My denominator will be what?
2 over 3.
3. What perfect square goes into 8? 4 times 2. I'm going to make my branches go off to the side there. Put square roots over top of both of them. Reduce the perfect radical, which is the square root of 4, which would be a 2. And then we were left with a square root of 2.
Why would you multiply?
Multiply what?
Because when you take the square root of 4, it would
Yep.
be 2.
Yep.
Why would it?
Because you have attached radical signs to both of them. So then it's the square root of 2. All right, now multiplying radicals. We did this back in section 6.1 with geometric mean. This should look very, very familiar to what you put in your notes on Tuesday. When you take the square root of one number and you multiply it by the square root of another number, you can just take the product of the two numbers and then simplify that radical. Which is pretty much what you were doing with geometric mean, hopefully, on your homework. Okay, so if I have the square root of 5 times the square root of 7, that would result in the square root of what? 35. Can I simplify that? Any of these divide into it? Nope, so I'm done. That is the simplified version. The square root of 5 times the square root of 15 is 75. Any perfect squares going into 75?
25, yeah.
And 3. Put a radical over top of both those numbers. So that would simplify to 5 square root 3. Good. Okay. Is that it, or do we have one more?
We have one more.
Okay. Oh yeah, it's 1,000, isn't it?
It's 1,000.
So we end up with the square root of 1,000. So Taylor is saying 100 times 10. So that would simplify to 10 square root 10. Okay, so for